All right, let's jump right into this explainer and decode exactly what OpenAI just unleashed with their new frontier model. Look, if you've been following the AI news cycle, you know that new model drops happen incredibly fast. But GPT 5.4, it brings some really fundamental shifts to how we're going to architect our applications. We're talking about capabilities that move way beyond just simple text generation, stepping right into genuine native automation. 47%. That is a massive number, and it's literally the amount of token overhead you can save with just one of the new features in this update. If you run complex agentic workflows, you know all too well that token bloat is the absolute silent killer of both latency and budget. Well, OpenAI is finally tackling this head-on, and honestly, the implications for your bottom line here are enormous. To unpack all of this, here is our agenda. 1. Meet OpenAI's GPT 5.4. 2. Native computer use. 3. A million token context. 4. Tool search efficiency. 5. The real benchmarks. And 6. Pricing and next steps. Okay, section 1. Meet OpenAI's GPT 5.4.
So GPT 5.4 essentially takes the absolute heavy-duty coding chops of Codex and it weaves them right into a general-purpose model built for professional work. Historically, we've had to choose between a model optimized for conversational reasoning or one optimized strictly for code execution. GPT 5.4 completely shatters that barrier. It gives you a unified, frontier-level model that handles complex reasoning and robust programming tasks at the exact same time.
It's rolling out across ChatGPT, the API, and Codex all at once in 3 distinct flavors. You've got the standard version for everyday tasks, GPT 5.4 Thinking, which utilizes advanced chain-of-thought reasoning to really methodically work through complex logic, and GPT 5.4 Pro, built specifically for the absolute highest demand enterprise workloads. And for consumers, that Thinking configuration is rolling out to Plus, Team, and Pro subscribers, which effectively replaces the older GPT 5.2 Thinking tier.
Moving right along to Section 2, Native Computer Use.
This is a real game changer for your pipeline. Native computer use is exactly what it sounds like. Previously, getting an AI to operate a desktop environment meant layering these highly fragile, specialized agentic frameworks on top of base models. You literally had to teach the model how to move a mouse or read a screen using external hacks. But now, GPT 5.4 handles it natively in Codex and the API. It can interact with your apps just like a human operator would.
So, if you're building automation pipelines, you can now just strip out that clunky abstraction layer. Taking third-party frameworks out of the equation radically simplifies your architecture. You still need to rigorously test for production reliability, for sure, but reducing those points of failure is going to fundamentally accelerate your development cycle.
Section 3. A million token context. For sprawling document sets or massive multi-quarter financial logs, having up to 1.05 million tokens means the entire context just sits right there in the window. If you've been heavily relying on retrieval-augmented generation, or RAG, just to chunk up huge codebases so the model can digest them, this experimental feature in Codex is huge. You can essentially drop an entire repository right into the prompt, completely bypassing the need for complex retrieval setups. But hey, you really gotta read the fine print here. Any requests pushing past 272,000 tokens get hit with a pretty heavy premium. Specifically, anything over that 272K threshold incurs a 2x penalty for input tokens and a 1.5x penalty for output tokens for the entire session. So yeah, you absolutely have to make sure the math works out for your specific workload before you just completely abandon your retrieval setups. It is incredibly powerful, but you are definitely paying for that convenience.
All right, Section 4. Tool search efficiency. Standard API calls have historically forced you to lug around the full specification for every single available tool in your ecosystem within every single request. If you have dozens of servers and tools, you're paying for thousands of unused tokens every call. Tool search completely flips the script. Instead of carrying that entire library of tool specs with you, the model simply pings the index when it decides a tool is relevant, fetching definitions entirely on demand. And the results here honestly speak for themselves. In OpenAI's internal testing, covering 250 tasks across 36 model context protocol servers, this on-demand retrieval triggered a massive drop in token usage. If you're building agentic workflows with large toolsets, this translates directly to that incredible 47% reduction in cost and latency per call we highlighted at the very start. It is a massive optimization for anyone running large-scale tool ecosystems. Let's look at the hard numbers. Section 5. The real benchmarks.
Okay, crucial reality check here. When you look at these self-reported percentages, you need to know OpenAI is benchmarking against GPT-5.2. They're not comparing this to the more recently released GPT-5.3. Keeping that exact baseline in mind is key to accurately gauging the performance leaps, especially when we talk about reasoning and computer navigation.
Let's look at a really concrete example. On OS World Verified, which measures complex desktop navigation using screenshots, keyboard, and mouse inputs, GPT 5.4 actually outperformed the reported human baseline of 72.4%, hitting a solid 75% success rate. To put that in perspective, the baseline model GPT 5.2 only scored 47.3% on this exact same evaluation. This proves that the native computer use feature isn't just some gimmick, it's demonstrably better than average human operation. And honestly, the wins just keep stacking up. On OpenAI's internal GDP-Val benchmark, which spans 44 professional occupations, it matched or beat industry pros 83% of the time. Plus, individual factual claims are 33% less likely to be incorrect, and overall responses are 18% less likely to contain errors. It even took first place on the Apex Agents benchmark. This makes it a highly, highly reliable choice for sustained professional tasks like investment banking, consulting, or corporate law. Finally, Section 6, Pricing and Next Steps. Let's talk dollars and cents. Input tokens sit at $2.50 per million, but definitely notice that incredibly low cached input price at just 25 cents. That is a steal. Output tokens are priced at $15 per million. Now, if your data residency requires regional processing endpoints, keep in mind there's a 10% uplift on those numbers. And as we discussed earlier, you absolutely must factor in the tool call fees and those massive 2x context penalties if you push past that 272,000 token limit. So, what are your immediate action items? First up, if you run tool-heavy environments, evaluate tool search immediately so you can capture those 47% efficiency gains. Second, sit down and actually model out the extended context costs before you just drop your RAG architecture. And third, spin up a testing environment to see if native compute use can finally replace your fragile third-party agentic frameworks. Which brings us to the ultimate question you need to be asking your engineering team today. With native computer use, simplifying pipelines, and on-demand tool search slashing both cost and latency, the real question is your current stack actually primed to take advantage of these massive efficiencies? The tools are here, the models are natively capable, but is your architecture ready to evolve? Definitely think about that as you plan your next sprint. Thanks so much for joining me on this explainer, and I'll catch you on the next one.